This question asks you to draw the two possible isomers of formic acid and then to indicate which is the preferred structure based on the formal charge. I'm going to assume you know how to draw Lewis structures by now, so I'm now going to go through those step by step. Here are the two isomers. So the formal charge is equal to the number of valence electrons minus the number of unbonded electrons on that element minus the number of lines going to that element. So we're going to go through it element by element. The red hydrogen and the red oxygen are labeled red just to differentiate them from the white oxygen and the white hydrogen. So we start with the red hydrogen. Hydrogen always has one valence electron. It has no unbonded electrons. It has one line, so 1 minus 0 minus 1 equals 0. For the red oxygen, oxygen always has 6 valence electrons. In this case, there are 4 unbonded electrons. There are 2 lines going to that oxygen. 6 minus 4 minus 2 is 0. Carbon, being in group 14, has 4 valence electrons. It has no unbonded electrons, but it does have 4 lines, so it has a formal charge of 0. The white oxygen, 6 valence electrons. It has 4 unbonded, so 6 minus 4 is 2. There are 2 lines going to it. 2 minus 2 is 0. And the white hydrogen has 1 valence electron. It really can't have any unbonded electrons. It has 1 line, so it has a formal charge of 0. So now we're going to do the same thing to the other isomer. We'll start with the red hydrogen, 1 valence electron, minus 0 unbonded electrons, minus 1 line, gives a formal charge of 0. The red oxygen, because it's oxygen, has 6 valence electrons. There are 6 unbonded electrons here. There's 1 line. 6 minus 1 gives a formal charge of negative 1. The carbon has 4 valence electrons. No unbonded electrons. There are 4 lines going to it. 4 minus 4 is 0. The white oxygen, being oxygen, it has 6 valence electrons. Here it has 2 unbonded electrons. There are 3 lines. 6 minus 2 minus 3 is positive 1. And the hydrogen has 1 valence electron. No unbonded electrons. 1 line for formal charge of 0. So now looking at the formal charges, we see that over here the formal charges are all 0, while over here we have a formal charge on the red oxygen of minus 1 and on the white oxygen of plus 1. So the formal charges on the left-hand side are closer to 0 than those on the right-hand side. So that would make this the preferred isomer.